Unit 2, Topic 8, solve an inequality using the subtraction and addition properties of inequality. This one is an example where it says solve the inequality and write the solution in interval notation. One thing that's important to remember, when you have an inequality like this, your solution could take on multiple values. It's not like b equals a certain value. And so you need to provide an interval for the solution because you need to show that more than one value could be the solution. So let's go ahead and solve for b and see what we get. So the first thing we need to do is add 27 to each side, right? We need to get rid of that 27. So it cancels over here. So we know that b is greater than 27. So that is our solution, but to write it in interval notation, and we know that it's going to be, right now we're only dealing with integers. We're not dealing with, like decimals. I'm sorry, with decimals. So then we would say that the answer is going to be 28 to infinity. That would be the proper interval notation that translates to. Okay, let's look at another example. All right, and the one thing I did want to point out, excuse me, is that since this is greater than and not greater than or equal to, this is a non-inclusive parenthesis. Remember, the square bracket is inclusive. So whenever we're dealing with infinity, we always use a non-inclusive bracket, and because specifically this one is greater than and not the greater than or equal to, this one here needs to be non-inclusive. All right, let's look at the next example. Here we have g minus 28 is less than or equal to 1. Now notice here we do have that greater than or equal to or less than or equal to. So that means we're going to have an inclusive bracket as part of our solution. So here we're going to add 28 to both sides. That cancels that one. So now we have g is less than or equal to 29. So now we know that 29 is on the high end of our interval of solutions, which is a closed bracket, or excuse me, an inclusive bracket, that square bracket. And we know that negative infinity, right? Because this could be anything. It could be negative 100, it could be negative 1,000, it could be all the way to negative infinity. And just like I said with positive infinity, when you have negative infinity, you use a non-inclusive parenthesis there. Remember that, okay? So that would be the proper interval notation for this solution. All right, let's look at one more example. Okay, clear page, here we go. We have solve the inequality and then also again write it in interval notation. So we have y minus 26 is less than or equal to negative 31. Again, there we have that less than or equal to, so it's going to have an inclusive square bracket. So we're going to add 20, oops, helps if I go back to the pen, add 26 to both sides. So this cancels, and we have negative 31 plus 26. That gives us a negative 5 on this side. So we know that y must be less than or equal to negative 5. So similarly to our last one, we're going to have negative infinity with the parenthesis, and then we're going to have negative 5. And because it's a less than or equal to, that translates to that square bracket that's inclusive. All right, so if you have any questions about solving inequalities with addition and subtraction, let me know.